So we are taking the pipe flow. So what are the various frictional losses in a pipe flow? The frictional resistance in a pipe, you can see that the frictional resistance will be at the surface of the pipe. It will oppose the flow. This is the frictional resistance. And this frictional resistance is equal to, so this is the flow, this frictional resistance is proportional to V square, that is velocity square, and it is proportional to density of the fluid and also the surface area in contact. And it is independent of the pressure of the fluid. And also it depends upon the nature of contact of the surface. Sometimes it may be smooth pipe, it may be rough pipe. So it also depends upon uh, the nature of the surface in contact. So the frictional force depends upon the velocity square, density, and the surface area in contact. So let us take a fluid flow. In a fluid flow, you can see that here we are considering only only two forces, that is pressure force and the viscous force. The gravitational force can be neglected because this is flowing horizontally. We are taking only the x direction here. And viscous force will be in the x direction and pressure force will be in the x direction. So you can see the viscous force here, that is F1, and pressure force here P2. If you take two sections 1 and 2 and take this control volume between 1 and 2, so the pressure force P1 here and P2 here. So if you apply the Bernoulli's equation, that is a modified form of Bernoulli's equation, you can see that at 1 this is P1 by Rg rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus the loss of head due to friction. It's the Bernoulli's equation. So loss of head HF is equal to P1 by rho g minus P2 by rho g. Because the velocity is equal, because the area of cross section doesn't change. So V1 will be equal to V2. V1 will be equal to V2. Now we need to find out the loss of head loss due to friction, and you know that the pressure force is equal to the viscous force. Both are balanced. If the flow is not accelerating, if the forces are balanced, then that means the pressure force will be equal to viscous force. That means the total force is equal to 0. That means the fluid is not accelerating. So we have already seen that the resistance due to friction is proportional to surface area into velocity square, and this is the proportionality constant F dash. And that depends upon the nature of the pipe and several other factors. So P1 minus P2 is equal to F dash into A surface by A into V square. So P1 minus P2 is equal to F dash into pi dl by pi by 4 d square into v square. Pi dl is the surface area and pi by 4 d square is the cross sectional area and v is the velocity square. So P1 minus P2 is equal to F dash into 4L by D into V square. So this can be reduced into P1 minus P2 by rho G is equal to F dash into 4L by D into V square by rho G. So P1 minus P2 by rho G is equal to 4F dash L V square by rho G D. So HF. So P1 minus P2 by rho G is the head loss due to friction, that is equal to 4F dash L V square by rho GD. So this can be written as, if you make a modification here, that is F dash by rho can be written as F by 2. This is another friction coefficient. So you can write this equation as HF is equal to 4FLV square by 2GD. And this is called the Darcy-Weisbach equation. And HF is equal to FLV square by, this can also be written as FLV square, let us write it as F double dash LV square by 2GD. And here F dash is called the friction factor. See here, F double dash is the friction factor. That means F double dash is equal to 4F. So it is better to remember this equation, that is 4FLV square by 2GD, where this F is the Darcy's friction factor. So this is the equation, that is Darcy-Weisbach equation, and F here is the Darcy's friction factor.